Okay, so for example number 10 class, we are given a drop of water or something like a droplet. Okay, and take note that it is at 80 degrees Fahrenheit. It is in contact with air and has a diameter of 0.02 inch. If the pressure, take note class ha, pressure within the droplet is 0.082 psi greater than the atmosphere, what is the value of the surface tension? Okay, so we are required here class of the surface tension, which is in our lecture, it is symbolized as sigma. Okay, now what is the formula again class of a surface tension? If you could recall, surface tension is defined as the change in your force per length. Okay, or simply it is force all over length. Now, based from our given, we don't have force, we don't have the length. But what we are given is only diameter and the pressure. And we are given here the data which is it is a droplet. Now, if we draw class a droplet, okay, something like that, right? Droplet of water. So if you can observe, the droplet of water is where, if we draw it, something like this, okay, it's a droplet of water, and then, so the pressure is here, can you follow? And the diameter is right here, this one here. Now, if we observe class, okay, since we have the pressure and we have the diameter, if you could recall in your strength of materials, okay, stress, this is stress stress, maybe we'll be confused by the surface tension here, but if you recall, stress is equal to pressure all over, force all over your area. Okay, stress, or this is the same as pressure there. So from here class, we can solve for force by simply multiplying pressure times your area. Now, what is the area of our droplet? So as you can see, the shape of the droplet is somewhat circular, right? This part right here, or the cross-sectional area. So if you could recall, area is pi d squared all over 4. Okay? So from here, we'll have pressure times pi d squared over 4. So this will be our equivalent of our force. Okay? So why are we doing this class? It's because we have to express our variables in terms of pressure and diameter. It's because that's our given here. Okay, we don't have the direct value of force and length, therefore we have to express it in terms of pressure and diameter. Now, that's for the pressure, that's for the force class. Okay, now how about for the length? How are we going to determine the length of our droplet? Now, if you could observe class, like we have said, it is somewhat circular, or let's say the droplet is just like this. Okay? Kasi itong figure na parang ganito is yung parang kakalabas pa lang niya sa source niya, no? Pero usually talaga yung drop is circular. So, how are we going to determine the length of the drop or a droplet? So as you can see, in order for us to determine that, we have to solve for its circumference. And if you could recall, the circumference of a circle is pi times d, which is, if you are familiar with the 2 pi r. Okay? So we will be using the pi d. Kasi like we have said, we have to express it in terms of diameter. Now, this will be equivalent to our length class. It's because the circumference is the one that perimeter, or someone that circumcises, what do you call this? Yung parang pinapalibutan niya yung circle natin. And it refers to the length like we have said. Now, going back to our original formula, sorry, there. So, substituting, okay? So, therefore, surface tension, so substituting the F, which is pressure times pi d squared all over 4, all over, your length is pi d. Pi d. Okay? So, what can we cancel out from here? So, we can cancel pi, 1 of the d, wala na. And the 4 will be go down or will go down and we'll have PD all over 4. Okay, so this will be our working equation to solve for the surface tension. So substituting class, we have 0.082 psi all over times, the diameter, which is 0.0200 inch. By the way, we don't have to convert. It's because PSI is what again? PSI is pound per square inch. Okay? And from that, we'll be able to what? To cancel out inch here, there, and your unit will become pound per inch. Okay? Pound per inch. So, using your calculator, so how much is this value here? So, we have 0.082 times 0.02 over 4. Okay, so we have 4.1 times 10 negative 4, and the unit is pound per inch. Take note again, pound is a unit of force and inch is a unit of length. And that's it, class. The solution for example number 10. By the way, I forgot, our standard unit for length is foot. So, instead of pound inch, we have to convert it to pound per foot. So, we should convert inch in foot. So, 12 inch in 1 foot. So, therefore, we have to multiply this answer times 12. 4.92 times 10 negative 3, and the unit is pound foot. Okay, and that is our surface tension there.